So what we're going to do is we're going to look at 4D applications of these linear sequences, these arithmetic sequences. So we're going to look at a couple of different applications. And again, some of them are going to be very familiar to you because you've spent, for example, the first one we did, what we're going to do is simple interest, which you spent quite a lot of time on last year. So we'll be looking at that. I will tell you that even though these are in this section, if you just want to use the simple interest formula, you may. You do not have to do them as a sequence for the exam. All right? So they said you don't need to use that formula, but you'll see the formula anyway. It's no big deal.
Is the simple interest formula on the formula sheet?
Yes. Okay? So if you remember the simple interest formula, the amount of interest is simply equal to PIN, where P is the principal, the amount of money that you start with or deposit. Can you not see it? Okay, sorry. So we'll just go to the book and look at a few examples of these so you can see where all of these pieces are coming from. And we'll define them as we go and look at the steps. Okay. So the first one is using simple interest loans and investments. So if you have simple interest, that just means yearly interest on the amount you either deposited or borrowed. Okay? And remember that P is called the principal. That's the amount you either borrow or deposit. I is the interest rate as a decimal, and N is the number of years. And the common difference, remember, simply means how much that something changes. So for these interest problems, the amount that it's changing is how much interest you earn every year. Does that make sense? So the change, or the common difference this time, is how much interest that you're either earning or paying over the course of the years, right? So what we need to do is we need to first calculate how much simple interest we're earning per year. And from that, we can then move into the formula. So if you look at the formula, it's P plus ND. And the reason it's not N minus 1 this time, it's just N, is, hold on a minute. That'll go away in just a moment. So the reason it's just ND is there is no 0 year when you're earning interest. You earn interest per year, so you have to have at least 1 year. Right? Because if you did 1 minus 1, you get 0. And there's never a time when you're working with these that you're going to have 0 year. Okay? It's got to be the first year. So that's why N is just going to be N, the number of years. There is no negative number of years, etc. Right. So what we're going to do is just look at this formula a little bit so that you can practice it. Our common difference is the amount of interest per year. And if you think about finding the amount of interest, the amount of interest you earn is just a percentage of the money that you deposit or that you borrow. Okay? So to find D, you're simply going to take the interest times the principal. And that's going to tell you how much money you earn per year. So very straightforward. Now that's straight from last year when you worked on these when you were doing the financial sections. So I times P. Then what we're going to do is plug that into the formula to be able to find the amount after a certain number of years. And again, the formula is the same, except that instead of N minus 1, we're just going to have N because there is no, again, 0 year. So let me just scroll up there so that you can see that. All right. So here we go. Let's look at the example here. So your formula is going to be the amount you earn equals the principal plus the number of years times your D, the difference, that's how much interest you earn, right? So we've got the principal amount added to the amount of interest that you earn is basically what you're talking here. So David invests $20,000 into a bank account. He'll be paid simple interest at a rate of 5% per annum, so 5% per year. Find the expression for A and the value of the investment after N years. So if A is the amount of the investment, then P is the principal, N is the number of years, and D is the amount of interest that he's going to earn. So we don't know how much, right, he's earning, but we do know that the principal, in this case, the amount that he's depositing is $20,000. And we know the interest rate is 5%, and 5% as a decimal is 0.05. And if we know these two values, we just multiply them to get our D. Okay? So, somebody want to multiply 20,000 times 0.5 for me, please, and tell me what my D is going to be? 1,000?
Yeah.
There we go. So it's as simple as that. And now we have all the information we need to find the amount that he's deposited after any number of years. So let's just say we want to know how much he has after 5 years. And again, the number of years is your N. Your D, the common difference, is how much it goes up. So that's the amount of interest each year. And your P, of course, is your principal. So it's just a matter of plugging those in. Principal is 20,000 plus our N is 5 times our D, which is 1,000. So that means that at the end of 5 years, because we're going to multiply that out, we'll get 5,000. At the end of 5 years, he's going to have $25,000 in his account. Okay. So the only difference is you have to remember that D, we're calling it the common difference, but remember, common difference is just another way of saying change. And it's a change year on year. And in this particular case, we're earning money, so it's always going to be added to. So that's why it's P plus that amount. Now again, if you panic on the test, you can do A equals PIN, which is on your formulas page. And you'll get exactly the same answer. So, if you had A equals 20,000 times our interest rate is 0, in a decimal is 0.5 times 5. If you multiply all of those together, you would end up with 25,000. Okay. Well, you'd get the interest amount first, and then you would add that to get your 25,000. All right? So you can get the amount of interest by using the formula as well. Okay? So you'd get your 5,000 here, which you'd then add to get the total amount of the loan. Okay? Either way you do it, it's going to be a two-step process. All right. So that one's pretty straightforward because you've used that simple interest formula quite a lot. The one you haven't done is what happens when we start talking about decay. Now remember, we talked about growth and decay. Growth means your D is what number? What kind of number? A positive number, right? So that means that your line is going up. Decay means that your D is a what? Negative number. So that means your D is always going to be going down. Okay? And so we're going to be talking about depreciation. With depreciation, the value is going down. So we're talking about a decay here. And in that case, the amount of money it's going to go down is a constant, so it's going to be our D, but it's always going to be negative. But the amount is found exactly the same way. So you're still going to find your D by taking the principal times your I. That's not going to change. Okay? But if it's depreciation, this is going to be a negative number. So you're going to be subtracting it. Now in the formula, and that negative is built into the formula, not built into the numbers that you multiplied, because it's still going to say 5% of $20,000, which is not going to give you a negative number. You just have to remember that because it's depreciation, you don't add those numbers, but you're going to subtract them. But if you look at the formula is exactly the same. And that's why I think you should probably practice with the formula. It's just principal minus the number of years times your D, instead of adding. So depreciation, you're simply going to subtract instead of add. With interest, you're going to be adding. You're going to be earning money. And those are the only two pieces of the formula that are different, the plus and the minus. So let's look at an example calculating the depreciation. So the value of a machine is flat rate depreciated by a value of 4% of its initial value every year. The flat rate depreciation simply means that it's the same every year. It doesn't ever change, right? Which is unlikely scenario, right? If you have an old car, then at the first year it probably depreciated a lot. The second year not so much, then not so much, then not so much. But then as it got older, a lot more, right? So it's usually not constant, but we have to think of these as constant in order to make these work. So if you're thinking that doesn't sound right, it doesn't make any difference. Okay? So first thing we need to do is find our D. All we need to do to find our D is take the principal times the amount. So you'll see there that in this particular case, the principal started out at $100,000 and it decreased in value by 4%. So they just took 4% of $100,000. Somebody want to do that math for me, even though it's written right there. So we get our D of $4,000. But since this is depreciating, we're not going to add that to our principal, but what? Subtract it. So we get the formula A equals our principal minus the number of years times our D. Simplifying that, amount equals the $100,000 minus, and then we multiply our D we know, so that's $4,000 times N. And that's why the N is at the end, because we know the number, and whenever we have a number and a letter, we always put the number in front. And from that, we can just plug in our number of years there and find the amount of depreciation for any number of years. So a matter of substitution. First, you're going to find your D. You're going to plug that into your formula. And then answer the question based on the number of years. Okay? So fairly straightforward. All right. Here, same thing. New car was bought for $26,000 in 2014. The value of the car is expected to reduce by 4.5% of its original value every year. You have your rule. Remember, first you have to find your D, which is typical of all of these series problems, right? Find your D, but this time you find it by multiplying because you have a percent. Then you do the value, and you can move on. Find the year in which the value of the car is expected to be less than half its original value. In that case, we have an A value. We want the car to be worth less than $13,000. So this one has slightly different because you're going to have, after you found your depreciation amount, right? We don't want to use the original amount. We now want to find out what the amount would be, or when that would happen, the N would be for this particular value. So look at how that changes the formula. So A is less than 13,000. So the formula stays the same. There's your principal minus your D times your N. But now we have an A value. So in place of A, we'll put the is less than 13,000. And then you're going to be solving for N. Now, I don't like the way they solve this equation. It's fine if you want to solve it that way. They show too few steps. So let's just walk through this one just so that you can remember how to solve the equation. So it's, or the N equation in this case, 26,000 minus, sorry, I'm going to lose it on this page. So it's 26,000. It's your principal minus your common difference was 1170 times your n, and not equals. We want that to be less than $13,000. Now, anytime you're dealing with inequalities, remember which side needs to be smaller. We want the value, that we want to find the number of years at which that is less than. So that's why we switched it over to the other side. If you did this, you're reversing the process. Now, you'd still find the same year, but you just need to be really careful, right? Because when you solve the equation, it's not going to matter. You just need to be careful when you say that. Now, if you did this, depending on who the marker is, they may or may not get you for it, right? Doesn't really make any difference which one when you're solving the equation. You'll still get the same number. All right, so let's solve this inequality. My whole goal is to get this n by itself, on one side by itself. Now, it's not by itself right now. It's connected to that piece of the term, but it also has this thing over here as well. So I'm going to move this 26,000. And is that 26,000 positive or negative? Positive. So to get rid of it, I'm going to add a negative one. So that means subtract 26,000. But if I subtract it from there, what? If you subtract it from one side, you have to subtract it from both sides. So that'll get that on one side. Gives me negative 1170n is less than negative 13,000. Yeah? But my n is still not by itself, so I need to get rid of the negative 1170. How is that negative 1170 attached to the n? Multiplication, and the opposite of multiply is divide. So we'll divide both sides by negative 1170. Now, the negative and the 1170 will divide away over there. The negative will divide away over there. Can somebody tell me what 13,000 divided by 1170 is going to give me? Sorry? 11 exactly? Okay, so 11. All right, so we rounded it to 11 years. Now, guys, do you remember when you're working with inequalities, what happens to that inequality symbol if we divide by a negative number?
It flips.
It flips over, so it's going to become there. So n happens after 11 years. So after 11 years, the car is only worth half its value. Okay? Again, lots of algebra review for those of you who haven't done some algebra in a while. Okay? So depreciation, again, is basically the same, but using a slightly different formula because you can't have 0 years or negative years. Okay? Do you see the formula for unit cost depreciation? Still depreciation. Yes? Okay. But this time, it's depreciating after a certain number of uses. So n is the number of uses instead of the number of years. So if you use something, its value goes down. So the only difference between these is that your n is going to be different. Okay? Now, let's look at an example real quickly so you can see where all the numbers are coming from. A lawnmower was purchased for $270. Every time it was used to mow the lawn, the owner estimates a depreciation value of 50 cents in the mower's worth. So, even less work here because I don't have to find out how much it's going down. How much is it going down? Vote?
Yes.
So in this case, you're already going to be given your D, the amount of depreciation. Every use, it's going to go down by a certain amount. In this case, it goes down by 50%. So it's the same thing. Depreciation means you're going to add it or subtract it. Subtract it. Depreciation means it's going down, guys. So you're gonna subtract it. So the formula is simply A equal. So the amount equals the principal minus your N times your D, and your D, and when it's a unit based one like this, is always going to be given to you. The uses base. And the n is the number of years? Nope. The n is the number of what? In this case, the number of uses, the time, how many times you use it. Right? Okay? So what we're going to do is just going to pop over to the book or the exercises and look at a few of these together. Now remember, you've got your notes in front of you, so be prepared to answer questions. Let me find out what questions we're going to be doing. One through 3 and 6, 7, and 9. Okay, come on, guys. Suppose you invest $5,000 in simple interest at 7.5% per annum. How much interest is paid to you each year? Now, think about the question that's being asked. They're asking you how much interest is paid to you each year. So, who can tell me what letter in the formula that means? How much interest is being paid?
That would be P. D.
There you go. D.
Isn't D P times I?
Exactly, because you're looking for how much. So remember, P times I tells you how much interest that you're earning. There you go. So that is your D. Remember, D stands for the amount it's changing. And the amount that's changing is how much interest you're earning, right? Every time you earn interest, your balance is going to change. So we're gonna find our D. So, all right, everybody get your calculators out. Jock, calculate for me how much interest I'm going to make on my $5,000 per year. In other words, what is my D? You can use it as a percent or a decimal. It doesn't matter because your calculator can do the percent for you.
How many years is it?
We're not doing that. It's just how much per year. Just P times I is all I'm looking for here.
You make $375 per year.
I'm sorry?
$375.
I'm sorry, guys. Shh, I can't hear. I'm sorry. 37?
$375.
Oh, $375. Thank you. So it's $375 interest per year. Do you agree? Okay, good job. All right. So now that we know how much interest, then we can work on finding out how much interest, what that means for every year. And in this particular example, they're going to do it for you in a table. Pay attention to these tables because you're going to ask to complete these tables and then as well as graph them. So that means that every year you're earning $375, right? But now look, they want the total value of the loan or the total value of the investment. So what is our principal in this case, guys? $5,000 it was invested. And the amount of interest we earn, that's capital I, if you'll remember your formulas from way back when, is $375 a year, which means that at the end of year 1, okay, now you can use the formula or you can just use simple arithmetic on this, doesn't matter. The formula is A equals principal plus or minus? Plus, because I'm earning interest. The amount of interest times your N, which is number of years. So in your first one, it would simply be 5,000 plus 375 times 1 is just 375. So for this first value, I don't have room to write it, would be 5,000. Sorry, I can't write. $5,375, right? At the end of the first year. And then each year, it's simply going to go up by how much? You bet. So if you want to use the formula, you could, but all you really need to do is take this value and add 375 to it, and then add 375 to it, and add 375. So, Noah, what would I have in year 2 then? I can't use the chart because I can't write that small. So my initial value here plus another 375. So I just found year 1, it's that, right? And here's how much I'm earning. So I'm just going to take that number plus this number. Can you tell me what I'm going to get? Sorry, 5,000 what? There you go. Okay? So now we know how much we have at the end of year 2. So at the end of year 3, we're simply going to add another lump of interest on. So, Ziggy, if I add another lot of interest of 375 to my year 2 value, what is that going to give me for my year 3 value? Here's the year 2 value.
Yeah, 234.
And then I'm going to add 375 to that. Where's your calculator? Come on. So once you have all the yearly totals, right? Then what you can do is you could graph that information, and that's what he was talking about. If the first year, that's your X value, right? The time series goes along the bottom. And for the first year, you would plot 5375. For the next year, you would plot 2, 5750. Then 3, 6125. And when you finish, those dots should all line up to make a what?
Linear line.
A straight line, yeah. So a linear. Yeah, it's linear. It'll be a straight line. All right. Do some of these, guys. Do not just put it off. I will put the homework assignment on your Spire page for you.
Thank you, sir.
Thank you very much. Have a wonderful day.